We know that a triangle angle sum is what? 180. Why is that? It has something to do with a straight line. If I extend this out, and then let's say I take this side and then I slide it over. So I'm going to take this and slide it over. Then this angle is equivalent to that angle. Oops. Right? And it turns out these two lines are parallel, and this angle are alternate interiors, so that angle is equal to this angle. And what do you notice? The three angles of the triangle form a perfectly straight line. Okay? Now, that's actually not true on Earth. If you draw if the Earth was perfectly smooth, no hills or valleys, if you draw a triangle on the Earth, the angles will not add up to 180. Never. You can, if the triangle is very, 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 very small, you can get really, really close. But let's think of the globe. Okay. Let's say you and your friend, wait, you guys don't have friends. Let's say you and another person are standing at the North Pole. And how do we draw straight lines on the Earth? A straight line on the Earth would mean you walk in a straight line and you go all the way around the Earth, and when you come back around, you're going to end up where you started, and you will cut the Earth into two identical pieces. That's what a straight line on the Earth means. Okay? So the equator is a straight line. So one of you walks in this direction, and you hit the equator. What is the angle formed by your path and the equator? It's going to be a right angle, right? So if you walk in this direction, you're going to have this other person walk in that direction, 90 degrees to you. Okay? So that person walks this path. The angle between your path and their path is a right angle. But when that person hits the equator, what is the angle between their path and the equator? It's also 90 degrees. Wait a minute. I have just built a triangle whose angle sum is 270. What? Well, the rules on a sphere, the geometric rules on a sphere, are different from the geometric rules on a flat surface. And it all comes down to parallel lines or triangle angle sum. So if you have a triangle and you measure all the angles and it equals 180, you can guarantee that that was drawn on a flat surface. If you measure the angles and they're greater than 180, then it was drawn on a sphere or something similar, an egg, or there are a lot of different shapes that would have the same sort of curvature. So if you draw a triangle on a sphere, it kind of looks like this. Okay? Now, I'm going to blow your mind a little bit. The longitudinal lines that go around the Earth are straight. But the latitude lines that go around the Earth are not straight. Right? If you were to walk from here to there, would your path look like a straight line on the Earth? No. In fact, if you were walking from left to right, you would have to take a big step with your right foot and then a slightly smaller step with your left foot, and that's going to cause you to curve. Why do we care? Well, maybe you don't. But just in case you do, I want to show you something. The mighty state of Colorado. right? A lot of you think Colorado is a rectangle because most maps are flat. And they have to kind of cheat to make Colorado look like a rectangle. So if I measure from here, get out of the way, to here, sorry, 278 miles. Okay, let's measure from here to here. I missed, but 270, same distance, right? Okay. These are longitudinal lines. The eastern and western borders of Colorado are straight lines. But watch what happens when I measure from here to here, 388, and then I measure from here, from here to here, 365. So apparently, the bottom of Colorado is 23 miles longer than the top of Colorado. And not only that, but look, that doesn't even follow the border of Colorado, because the lines that go around the earth horizontally are not straight lines. And one way you can really see this, if we zoom out, and so there's the top of the United States. If I wanted to walk from here to there, that would be a straight line. But the top of the United States, which is like the 49th parallel or the 47th parallel, something like that, that line is not a straight line. If you wanted to build a fence along the top border of the United States and you look down that fence, it would curve. It has to. So it turns out there's no such thing as a rectangle on the sphere. It can't happen. So right now, Colorado has that's Wyoming. Colorado has 4 right angles in every corner, but the left and right are the same length, but the top and the bottom are different lengths. If you forced it so that all of the sides were the same length, then you would not have 4 right angles. You could have 3 right angles and one that wasn't a right angle, or 4 angles that were equal, but they're not 90 degrees. So you cannot draw a rectangle on a sphere. It's impossible. Either the side lengths are not straight, or they're not the same length. It causes a lot of problems. So some of you are farmers, and you think your fields are rectangles, or wherever you live, you think that the land you live on is a rectangle. Well, that's not true. Okay, watch this. What happens when we try to divide Utah into squares? Okay, so we just draw a whole bunch of lines and a whole bunch of lines, and we create squares. Well, you can't draw squares on a circle, on a sphere. It doesn't work. So as we zoom in, you're going to see that there are all sorts of problems. Okay, we would like all of these squares to be the same size. But if this square has 4 equal sides and this square has 4 equal sides, eventually we're going to get to a place where the square can't have 4 equal sides. So let's focus in on Castledale. We're going to zoom in a little bit. So maybe you have a farm near here. Oh, you can't see. Oh, there we go. Good. Come on. See how none of them are quite right? Right? We got some squiggle lines up here, and that's actually not too bad. Let's see how messed up that line is. And then eventually we're going to run into places where it looks terrible. Look at that. Something's got to give. These don't even line up anymore. And look, this one's got an extra square in it. Oh, that's not even close to a rectangle. So all of the geometry that you've learned so far is based off of doing geometry on a flat piece of paper. Well, the problem is there are no flat pieces of paper on the earth. Look at that. I mean, that one doesn't even have 4 sides. It has 6 sides. So anyway, so why do we teach flat paper geometry? Because on a really small scale, it doesn't matter. If you're building a high school, you can pretend that the ground is flat and it works. If you're building a fence across from one side of a state to another, then you're going to have to worry about curves. If you're building a freeway across the country, then you have to worry about it. But for almost all construction, we can just pretend that the earth is flat. Okay? So, I'm actually not done yet. So, if a triangle has an angle sum of 180, what is the angle sum of a 4-sided shape? Why is it 360? We know that a square has 4 right angles and a rectangle has 4 right angles, and that adds up to 360. But this is not a rectangle. How do I know it adds up to 360? Anybody know? Well, what if I split it into triangles? That was really nice. Okay. What is this angle plus this angle plus that angle? 180. So the sum of the angles in the triangle is 180. What about this angle plus this angle plus that angle? That would be 180. And what about all of the angles in that quadrilateral? It would be all of the blue angles plus all of the purple angles, which is 360. And no matter how I move that shape around, I always have 2 triangles. What if it was a 5-sided object? Well, we pick a vertex, doesn't matter which one, and then we draw as many triangles as we can. 3 triangles. So 180 plus 180 plus 180 is 540. So this has an angle sum of 540 degrees. What if it was a hexagon? How many triangles are there? 1, 2, 3. Or sorry, 4. 1, 2, 3, 4. 4 times 180 would be 720. What if it had 15 sides? Why 13? Oh, you saw the formula. Good. How many triangles does a polygon have? Well, it depends on how many sides there are. What's the relationship between the number of sides and the number of triangles? Well, a 3-sided shape has 1 triangle. A 4-sided shape has 2 triangles. A 5-sided shape has 3 triangles. So the number of triangles is always 2 less than the number, 2 fewer than the number of sides. So a 15-gon would have 13 triangles, so the angle sum would be 13 times 180. And if you ever forget the formula, just draw the triangles. You have an octagon, pick a vertex, draw the angle, draw all the triangles, count them up, times by 180. There will probably be a question like this when you take the ACT, on every ACT test you take. Something to do with angle sums of polygons. Now, what if it's not convex? So let's try this. Is that still going to work? Well, we have 1, 2, 3, 4, 5, 6, 7, 8 sides. And how many triangles do I have? 1, 2, 3, 4, 5, 6. Still worked, right? Okay. So here we know the angle sum is going to be 360. I have 3 of the 4 angles, so just take 360, subtract 80, subtract 128, and subtract 102. Okay. If we know that there is a convex polygon, meaning it doesn't dent into itself, and the angle sum is 1080, how many sides does it have? Well, we need to figure out how many triangles it would have. So how do we find the number of triangles? So, good. We take 1080. Let me pull my calculator up. So 1080 divided by 180 gives me 6. What does 6 tell me? There are 6 triangles in this shape. So a shape with 6 triangles must have 8 sides. Okay. Oops. All right. This is a pentagon. How many triangles does a pentagon have? 3. So 3 times 180 is 540. Subtract all the known sides, and you end up with the value of x. If we have an 11gon, how many triangles would that be? 9. 9 times 180 will give you the sum of the interior angles. Okay. What does it mean for a shape to be regular? Has nothing to do with how much fiber it eats. All the angles are the same, and all the sides are the same. Give me an example of a regular polygon. An equilateral triangle, a square, a stop sign, right? All of the sides are equal, and all of the angles are equal. So in this case, we have a 6-sided polygon that's regular. So it would be a hexagon that looks like this. Okay? How big is that angle? How would you figure that out? Well, what would the angle sum of all of the angles be? So how many triangles does a hexagon have inside of it? 4. So 4 triangles times 180 is 720. That tells me all of the angles added together. So how do I figure out the size of one of the angles? Divide 720 by 6. How come I'm allowed to do that? They're all the same. It's regular. So we divide this by 6, and I get 120. So the interior angle is 120, and that's true of all of them. Okay? What does it mean to be an exterior angle to a polygon? If you take one of the sides of the polygon and you just continue past the vertex, this is called an exterior angle. How big is that exterior angle? 60. Because an interior and an exterior angle are supplementary, so that would be 60. So there is a formula for the interior angle of a regular polygon. Number of sides minus 2 times 180 divided by the number of sides. But there's also an angle for the exterior, or there's also a formula for the exterior angles, and it's way easier. If I look at all of the exterior angles, okay, this one, this one, this one, this one, this one, and this one, those angles add up to 360 every single time. Okay? They always add up to 360 no matter what, if it's convex. Okay? If it has that weird concave that messes everything up. But so what we could have done is the exterior angles are 360 divided by the number of angles, which would be 60. And that would tell me that this is 60, and then I could figure out that that is 120. So both of those formulas come to the same conclusion. All right, an interior angle is 144. So I have an unknown number of sides, but I know that the interior angle is 144. How do I figure out how many sides it has? Well, I could do 144 times the number of sides, right? Yeah, we could. Let's see what happens when we try this. So 144 divided by the number of sides gives me the total angles. And then what do you do with the total angles? You would divide it by 180, and that would tell you the number of triangles. And then you would take the number of triangles and add 2, and that would tell you the number of sides. And you can actually do that using algebra. It's just kind of complicated. The easier way to do it, Damon. So how big would this be? So this is 36. And if I add all of the exterior angles together, I get 360. And how big is each angle? 36. 360 divided by 36 is 10. So this would be a 10-sided polygon, a decagon. What's the prefix for 9? Nonagon. What about 7? Heptagon. What about 11? I don't know. 11's probably got one. What about 12? Dodecagon. 20? Icosagon. Yeah. So 10 is decagon, 12 is dodecagon, and then 20 is icosagon. What if it's 55? We just say 55 gone because we're lazy. All right, that's it. Get to work.